Hello again and welcome to another JAS Land Rovers video. Earlier this week on our Facebook page we stuck this photo on there asking a bit of a test. What are we doing? What's wrong? What would we do next? So this is a relative compression test. A couple of you got that right. A quick explanation of that is this uses the current going through the starter motor as we're cranking the engine to figure out compression, relative compression, one cylinder to the next. Of what the compression is in the engine. You could have figured that out just by looking at the left-hand side. If you look at the left, you've got the scale there. That's in kiloamps. So up the side, you've got nearly 1,000 amps, settling down to between 300 and 400, peaking there. So why is it a relative compression test? Because it doesn't actually give us any compression. No, it doesn't give us the direct compression. It doesn't give us an absolute compression. There's no measurement for PSI or pressure in there. What we're doing is comparing one cylinder to the next cylinder using how hard it is for the starter motor to compress each cylinder in turn. So if one cylinder is much harder to compress than the next one, then the amperage will be higher, therefore you'll get a higher peak. Conversely, if one cylinder is much easier to compress, so much lower compression, you'll get a lower amp reading, so much lower current and a lower peak on the graph. So that's the blue line. You can see initially that spikes up over about 1,000 amps and then settles down to this regular repeating waveform. We're just going to zoom in on the next page to that bit where it says C sheet 2, but for now you can see the blue trace. That's our starter motor current, and you can actually see some red spikes as well. That's us trying to show which cylinder is which, because obviously if all we get at the end of the day is a repeating squiggle, we don't know which cylinder is which. We need to identify which cylinder is which. So that red, that's injector current. So an injector is firing. Obviously there's 6 cylinders, 6 injectors. We've got starter motor current in blue, and we've got injector current on one particular cylinder, on one particular injector in red. And we can use that one red trace to figure out exactly which cylinder is which using the firing order of the engine and our knowledge of which cylinder is which in terms of which number cylinder is which physically on the engine. So we say we're going to zoom in on sheet 2. Well, here is sheet 2. Quite a lot more detail there. That's only a couple of revolutions of the engine. If you look along you've got the red line. Just below that you've got a 0 degrees, and then you've got 720 degrees a bit further on. That 0 to 720, that's 2 revolutions of the engine, or one 4-stroke cycle, one complete 4-stroke cycle. So that should have all of our cylinders, all 6 cylinders firing, compressing and firing within that 0 to 720 degrees. So if you're looking at the blue trace, obviously we've got a bit of a problem. We've got 5 peaks where we have 6 cylinders. So 5 peaks is 5 cylinder compressions, and then we've got a big gap, no peak right there on, I think it's about 2.224 seconds, and we're going to identify that a bit more clearly now using the red trace. So the red trace, that's the injector current. We actually we're measuring injector current on injector number 2, or rather cylinder number 2, which was the easiest one to get at the time. So we're just going to stick some cylinder numbers in there. If we stick the 2 on cylinder number 2, we know that our firing order is actually cylinder number 1 first, then 4, then 2, which is the one we've synced on, then 5, then 3, then 6. So they're all on there now. Let's have a look at what that makes. So cylinder number 1 is there on 0 degrees. We're starting measuring at 0 degrees for cylinder number 1. Then number 4, then cylinder number 2 with our red trace from the injector firing, then 5, then 3, then 6. So you can see that 5 of those cylinders, 1, 4, 5, 3 and 6, are all fairly even in terms of the height of the peaks. So even current draw, therefore even compression across those 5 cylinders. And then cylinder number 2, no compression whatsoever. There was no increase in current for that to compress that cylinder, so therefore effectively no compression. There aren't many things that would give us no compression, but with that in mind, the next thing to do is identify exactly why we've got no compression in that cylinder. Knowing that we've got no compression, that can only be really a physical problem, and to investigate that problem based on this one bit of paper, we did this. Yep, you guessed it, we took the body off. 10 minutes with Picoscope, a full relative compression test. Try doing that in 10 minutes with an absolute compression test with your compression tester. It's not going to happen. 10 minutes, one bit of paper, that's enough to convince us to take the head off. This is pretty much what we wanted to see. That is cylinder number 2, the exhaust valve in cylinder number 2 stuck open. It's not sealing, it's not able to seal in the compression, therefore we're getting no compression. It was due to a broken valve spring. Excuse the kids. So what did we do? We sent that head away, that head came back, all repaired, lovely and shiny, really light reface on the face of the head, new cylinder head gasket, inlet manifold gasket, new timing belts, lots of various gaskets, new oil, filter, studs, etc. Head looked pretty good, I quite like that to be fair, cleaned up nicely. Yeah, that exhaust valve on that centre cluster, the top one as we were looking at, that's the one that was stuck open. So put the engine back together, head back on the engine, body back on the car, turn the key, and it runs absolutely fine. No more misfiring, no more judder. That car came to us all the way from Birmingham. Birmingham to York on a recovery truck isn't an inconsiderable distance. Really appreciate the customer taking it all the way, or giving us the chance to fix it. He had a couple of problems with local garages, misdiagnosing the problem. He'd heard about us on Facebook and got it brought to us. More than happy to help. We like diagnosing things properly. We like fixing problems quickly and properly. That's it. That's us for today. Hope you enjoyed this one, and we'll see you next time. Thanks very much, guys. JAS Land Rovers out.